Hello, in this lecture we'll find out the area of the circle. In the drawing we have quadrilateral ABCD. Inside this quadrilateral we have the circle. In addition, you know that side AB of the quadrilateral is equal to 2 units. Side BC equals to 8 units. Side DC also equals to 8 units. This angle DCB equals to 90 degrees, and this is angle ABC that is also equal to 90 degrees in its size. Our mission is to find out the area of this circle. So, in order to find out the area of the circle, we will do a construction. We will extend side DA and side CB of the quadrilateral by a straight line until they touch each other. The extended sides touch each other at this point. We define the touching point as M. So actually, line segment BC is one side of quadrilateral ABCD, therefore it is absolutely a straight line. When we extended the straight line CB by a straight line, the result is line segment CM. So when you extend a straight line by a straight line, the result must be a straight line. Therefore, line segment CM, it is also a straight line. So if we focus on the upper side of the straight line CM at point B, here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of CM at point B? We have this angle that is equal to 90 degrees plus the missing angle ABM. In total, the sum of those two angles must be equal to 180 degrees according to the rule that I mentioned. Therefore, actually, the missing angle here must be equal to 90 degrees. Angle ABM must be equal to 90 degrees. In order to complete the sum of the angles on the upper side of the straight line CM at point B to 180 degrees, the missing angle here must be equal to 90 degrees. We focus on the right triangle ABM. We define this angle AMB as theta. So in the right triangle ABM, we have this angle that is equal to 90 degrees. This angle equals to theta. Therefore, the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta, it is equal to 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. In the next step, we'll focus on the big right triangle MDC. On this big right triangle MDC, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. Exactly like in this triangle, exactly like in the small right triangle AMB. In the next step, we will prove that the big right triangle MDC is similar to the right small triangle AMB. Repeat again, we will prove that the big triangle MDC, the big right triangle MDC, is similar to the small right triangle AMB. So, why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. So, angle DCM in the big triangle is equal to angle ABM in the small triangle. Repeat again. Angle DCM in the big triangle is equal to angle AMB in the small triangle. Again, angle DCM in the big triangle is equal to angle ABM in the small triangle. They are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, that is a common angle, it belongs to both triangles, so we can write down that angle theta equals to itself. You can define angle theta into different, you can call to angle theta two different names. Angle theta can be called as angle DMC, and it is equal to angle theta itself. You can call angle theta also as angle AMB. So, the meaning of this equation is that angle theta equals to itself. We just called to angle theta two different names. Angle theta is a common angle that belongs to both triangles. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So we can write out that angle CDM in the big triangle is equal to angle MAB in the small triangle repeat again, angle CDM in the big triangle is equal to angle MAB in the small triangle. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually proved that all the three angles in the big triangle MDC are correspondingly equal to all the three angles in the small triangle AMB. Therefore we actually proved that the two right triangles are similar to each other according to angle similarity rule. I'll write it down. The big triangle MDC is similar This is the side of similar to the small triangle, triangle AMB, holding to angle similarity rule. And for the fact that the two right triangles are similar to each other, we derive that the following relationship exists between their sides. That MC in the big triangle over MB in the small triangle is equal to DC in the big triangle over AB in the small triangle. I'll repeat again. MC over MB, it is equal to DC over AB. What is the length of side MC? From the drawing it is easy to see that MC equals to MB plus BC. That is to say MC equals to MB plus BC, that is 8. So in total MC equals to MB plus 8. MC is MB plus 8 over MB, that is equal to DC. DC is 8, AB equals to 2. 8 over 2 is 4, so MB plus 8 over MB, it is equals to 4. We will multiply this equation by MB and we will get that MB plus 8 equals to 4 times MB. We subtract MB from this equation and we get that 8 equals to 4MB minus MB, it is 3MB, so 8 equals to 3MB. We divide this equation by 3 and finally we get that MB equals to 8 over 3 units in its length. So here the length of side MB or line segment MB equals to 8 over 3 units. In the next step we will implement the Pythagoras theorem and the right triangle AMB. So here by PT is the evaluation for Pythagoras theorem. According to Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle AMB is AM, therefore the square of the hypotenuse is AM square. And it must be equal to AB square plus MB square. So I'll repeat again. The right triangle AMB according to the Pythagoras theorem, AM square equals to AB square plus MB square. So AM squared equals to AB squared. AB is 2, so AB squared is 2 squared, that is 4, plus MB squared. MB is 8 over 3, therefore MB squared is 8 over 3 squared. So AM squared is equal to 4 plus 8 over 3 squared is equal to 8 squared, that is 64, over 3 squared, that is 9, so AM squared equals to, here we'll multiply 4 by 9 and then we'll divide it by 9 in order to overcome factor of 64 over 9. So 4 times 9 is 36, so in the numerator we'll have 36 plus 64 over 9. 36 plus 64, it is 100, so it is 100 over 9. We take out of this equation and we'll get that AM equals to the square root of 100 over 9. The square root of 100 is 10 and the square root of 9 is 3. So in total we found out that AM equals to 10 over 3. So the hypotenuse AM here is equal to the length of the hypotenuse AM is 10 over 3 units. In the next step, I present to you rule number 1 and we'll implement rule number 1 in our drawing. According to rule number 1, the tangent to a circle is perpendicular to the radius drawn to its point of tendency. So we have here tangent AB is tangent to this circle at point M. We have the radius OM that is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever we have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. So if AB is perpendicular to MO, it means that this angle equals to 90 degrees and this angle equals to 90 degrees. So we'll implement rule number 1 in our drawing. First of all, we'll define the center of this circle at this point as O. We'll define the point of tendency between side AB in the circle as M. In the next step, we join points O and M together by a straight line. Point O is the center of the circle. Point M is the point of the circle itself. Therefore, OM is the radius of the circle. We define the radius of this circle as x. Therefore, OM equals to x. It is the radius of the circle. The radius OM is drawn to point M, that is the point of tangency of tangent AB with this circle. And whenever we have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. So if AB is perpendicular to MO, it means that this angle equals to 90 degrees. And this angle also equals to 90 degrees according to rule number 1. We define the point of tendency of side BC with this circle as N. The next step, we join points O and N together by a straight line. ON is the radius of the circle that is equal to x. the radius ON is going to point N, that is the point of tendency of tangent BC with this circle. Whenever you have a radius that is going to the point of tendency, then tangent BC will be perpendicular to the radius NO. If BC is perpendicular to NO, it means that this angle equals to 90 degrees, and this angle equals to 90 degrees according to rule number 1. So, in quadrangle OMBN, we have 1, 2, 3 right angles. The sum of 3 right angles is 90 times 3 is 270 degrees. Plus the missing angle, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees. In order to complete the sum of the angles in this quadrangle to 360 degrees, the missing angle here must be equal to 90 degrees, because 270 degrees plus 90 degrees, it is equal to 360 degrees. Okay, so in the next step we will draw perpendicular on BC in such a way that it will be also tangent to the circle. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We'll define the touching point of the perpendicular and side BC as G. We define the point of tendency of the perpendicular with the circle as H. We will extend the perpendicular GH until it touches side MD of the triangle. And we find the touching point of the extended perpendicular GH and side MD as T. So here tangent DTG, this tangent TG is tangent to this circle at point H. Point H is the point of tendency. We join points O and H together by a straight line. OH is the radius of the circle that is equal to X. The radius OH is drawn to point H, that is the point of tendency of tangent TG with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent TG will be perpendicular to the radius HO. If TG is perpendicular to HO, it means that this angle equals to 90 degrees. This again equals to 90 degrees according to rule number 1. So in quadrangle ONGH we have 1, 2, 3 right angles, therefore the fourth angle must be equal to 90 degrees. According to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. So angle MOH, this angle, it is equal to 90 degrees plus 90 degrees. It is equals to 180 degrees. Again, angle MOH equals to 180 degrees. Any angle that is equal to 90 degrees, any angle that is equal to 180 degrees, like this angle MOH, must be a straight line. Therefore, MOH is a straight line. If MOH is a straight line, then MH must be also a straight line. So MH is a straight line. But MH is a straight line that touches the circle at point M and H, those 2 points. Therefore, MH is a chord that passes through point O, that is the center of the circle, and any chord that passes through the center of the circle must be the diameter of the circle. Therefore, m edge that passes through the center of the circle must be the diameter of the circle. So we can write down that m edge is the diameter of the circle. M edge is the diameter of the circle. In the next step, we will focus on quadrangle MHBG. Again, quadrangle MHBG. Inside this quadrangle, we have 1, 2, 3, 4 right angles. Any quadrangle that has 4 right angles must be at least a rectangle, if not a square. So quadrangle MHBG, we will relate to quadrangle MHBG as a rectangle. But we also know that the opposite sides of a rectangle are equal to each other. So, in rectangle MHBG, side BG must be equal to side MH. Or MH is equal to BG. So write down here that MH equals to BG. And from this equation, BG equals to MH equals to the diameter, we will derive that BG is also the diameter of the circle. But we also know that the diameter of any circle is twice as long as the radius. And the radius of this circle equals to x, therefore the diameter of BG must be equal to 2x. BG equals to 2x. We can write here that the length of line segment BG, or the diameter of BG, this line segment BG, is equals to 2x. In the next step, we'll focus on the big right triangle MTG. On this big right triangle MTG, this angle equals to theta, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus theta, as I already explained before. So, in the next step, we'll prove that the big right triangle TGM is similar to the small right triangle ABM. Repeat again, we prove that the big right triangle MTG is similar to the small right triangle AMB. So, why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. So we can write down that angle TGM in the big triangle angle TGM in the big triangle is equal to angle ABM in the small triangle. Repeat again. Angle TGM in the big triangle is equal to angle ABM in the small triangle. They are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, that is a common angle. It belongs to both triangles, so we can write down that angle theta equals to itself. Angle theta can be called as angle TMG. And it equals to itself. We can define angle theta as also angle A and B. Actually, this equation means that angle theta equals to itself. We just call to angle theta two different terms. Angle theta is the common angle that belongs to both triangles. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So angle GTM in the big triangle equal to this angle, angle BAM in the small triangle. Angle PTM in the big triangle is equal to angle BAM in the small triangle. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually proved that all the three angles in the big triangle MTG are correspondingly equal to all the three angles on the right small triangle A and B. Therefore, the two right triangles are similar to each other according to angle similarity rule. So I write it down. The big triangle MTG is similar to the small triangle A and B according to angle similarity rule. And from the fact that the two right triangles are similar to each other, we conclude that the following relationship exists between their sides. We conclude that MG in the big triangle over MB in the small triangle is equal to TG in the big triangle over AB in the small triangle. Repeat again and conclude that MG over MB equals to TG over AB. I've already explained to you that MG equals to MB plus BG. That is to say, MG equals to MB, that is 8 over 3, plus BG, that is 2x. So in total, MG equals to 8 over 3 plus 2x. Over MB. MB is 8 over 3. And it is equal to TG. TG is unknown, so we leave it as it is. Over AB. AB is 2, so we substitute AB by 2. So in conclusion, we found out that 8 over 3 plus 2x over 8 over 3 equals to TG over 2. Here we multiply 2x by 3 and then we divide it by 3 in order to have a common factor with 8 over 3. And we get that in the numerator here we will have 8 plus 2x times 3 is 6x, so in the numerator we have in total 8 plus 6x over 3 over 8 over 3, that is equal to tg over 2. So here we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled, and we're left only with this side of the equation with 8 plus 6x over 8, that is equals to tg over 2. Here we cross multiply this equation, and we get that two times 8 plus 6x is equals to 8 times tg. We divide this equation by 2, and we get that 8 plus 6x is equals to 8 over 2 is 4, so in total this expression equals to 4 tg. Here we divide this equation by 4, and finally we get that tg equals to 8 over 4 is 2, plus 6x over 4 is 1.5x. So in total, tg equals to 2 plus 1.5x. So I can write down here the original drawing. In this 9 segment tg or gt, it is equals to 2 plus 1.5x. Okay. Because of the fact that the big right triangle TMG is similar to the small right triangle AMB, we conclude that addition relationship exists between their sides. We derive that MG in the big triangle over MB in the small triangle is equal to TM in the big triangle over AM in the small triangle. Repeat again. MG over MB equals to TM over AM. I already explained to you that MG equals to 8 over 3 plus 2x. Well, MB is 8 over 3. Is equals to TM. TM is TA plus AM, that is to say TM is TA plus AM, that is 10 over 3. So in total TM equals to TA plus 8 over 3. Plus AM. AM is 8 over 3. I concluding found out that 8 over 3 plus 2x over 8 over 3 equals to TA plus 8 over 3 over 8 over 3. Here we multiply 2x by 3, and then we divide it by 3, and also we multiply TA by 3, and then we will divide it by 3. And we get that here in the numerator we have 8 plus 2x times 3 is 6x. So in the numerator in total we have 8 plus 6x over 3 over 8 over 3, that is equals to 3 times TA is 3TA plus 10. So in the numerator in total we have 3TA plus 10 over 3 over 10 over 3. So in this side of the equation we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. On the other side of the equation we have also 3 in the numerator and 3 in the denominator, so 3 also will get cancelled. So here, this side of the equation we left only with 8 plus 6x over 8, that is equals to, in the other side of the equation we have 3 times TA plus 10 over 10. Here we cross multiply this equation and we get that 10 times 8 plus 6x is equal to 8 times 3TA plus 10. So here we'll open the brackets on both sides of the equation and we get that 10 times 8 is 80 plus 10 times 6x is 60x. That is equals to 8 times 3TA is 24TA plus 8 times 8 is 80. So here we have 80 on both sides of the equation, so 80 will get cancelled and we're left only with 60x that is equals to 24TA. So here we'll divide this equation by 24 and finally we'll get that TA equals to 60x over 24 is equals to 2.5x. So in conclusion we found out that the length of line segment TA is equals to 2.5x units. The length of this line segment TA is equals to 2.5x units. So write it down in the original drawing that the length of this line segment TA is equals to 2.5x units. In the next step, I will copy quadrangular ATBG in a new page. Actually, this is quadrangular ATBG that I copied from the original drawing. This quadrangular ATBG blocks a circle. This is the circle that the quadrangular blocks, so I copied the circle in the new drawing here. So this is the circle that I copied from the original drawing. The quadrangle and the circle touch each other at 4 different points. 1, 2, 3, 4, or we can say that they are tangents to each other at 4 different points. Those 4 points, so we define the first point of tendency as M. We define the second point of tendency here as N. We define the third point of tendency as Y, and we define the fourth point of tangency between the quadrilateral and the circle as h. In the next step, I present to you rule number 2 and we implement rule number 2 in our drawing. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. We have here the common external point, point P. From the common external point, point P, we have two tangents to this circle, tangent PA and tangent PB. According to rule number 2, this one, they are equal to each other. That is to say, PA equals to PB. So whenever you draw from a common external point two tangents to a circle, then the length of those two tangents must be equal to each other. In this case, PA equals to PB. We can implement rule number 2 in our drawing. So here we focus on the common external point, point A. From the common external point, point A, we have two tangents to this circle, tangent AM and tangent AN. And according to rule number 2, they are equal to each other. That is to say, AM equals to AN. So actually, if we define the length of tangent AM as A, then AN must be also equal to A because they are equal to each other. Likewise, we focus on the common external point, point B. From the common external point, point B, we have two tangents to the circle, tangent BN and tangent BY. And according to rule number 2, they are equal to each other. That is to say, BN equals to BY. So, if we define the length of BN as B, then BY must be also equal to B. In the next step, we focus on the common external point, point G. From the common external point, point G, we have two tangents to this circle, tangent GY and tangent GH, and according to rule number 2, they are equal to each other. That is to say, GY equals to GH. So if we define the length of GY as C, then GH must be also equal to C. And finally, we focus on the common external point, point T. On the common external point, point T, we have two tangents to this circle, tangent TM and tangent TH. And according to rule number 2, they are equal to each other. That is to say, TM equals to TH. So if we define the length of TM as D, then TH must be also equal to D. In the next step, we will add side AT to the opposite side, side BG, in quadrilateral AT-BG. So what is the value of AT plus BG? For the drawing, it is very easy to see that AT equals to A plus D. So we substitute AT by A plus D. Plus BG. From the drawing, it is very easy to see that BG equals to B plus C. So we substitute BG in the equation by B plus C. So in conclusion, we found out that AT plus BG equals to A plus D plus B plus C. Here we can change the orders of the 4 letters. Instead of A plus D plus B plus C, we can write down that this expression equals to A plus B plus C plus D. Again, those two expressions are equal to each other. We just change the orders of the letters. In the next step, we will add side AB to the opposite side, TG. So AB plus TG. AB plus TG. AB equals to A plus B, and TG equals to C plus D. In conclusion, we found out that AB plus TG, it is also equals to A plus B plus C plus D. Exactly, that's the value of the expression of AT plus BG. They are both equal to A plus B plus C plus D. Therefore, they must be equal to each other. That is to say, AT plus BG equals to AB plus TG, again because of the fact that both those two expressions, they are equal to the same expression A plus B plus C plus D. They must be equal to each other. So AT plus BG equals to AB plus TG. Here AT equals to 2.5x, so we substitute AT in the equation by 2.5x plus BG. BG equals to 2x, so we substitute BG in the equation by 2x, and it is equals to AB. AB is 2, so we substitute AB by 2. Plus TG. TG equals to 2 plus 1.5x, so we substitute TG in the equation by 2 plus 1.5x. So finally we found out that 2.5x plus 2x equals to 2 plus 2 plus 1.5x. 2.5x plus 2x is 4.5x. And it is equals to 2 plus 2 is 4 plus 1.5x. Here we subtract 1.5x from this equation and we get that 4.5x minus 1.5x is 3x. So 3x equals to 4. Here we'll divide this equation by 3 and finally we get that x equals to 4 over 3 units in its length. We found out that x, the radius of this circle x, equals to 4 over 3 units. Our mission is to find out the area of this circle. So, the area of any circle, here the squared brackets is the sign for the area. So the area of any circle, it is equals to pi times the radius squared. If the radius is defined as r, then it is pi r squared. In our specific circle, we define the radius as x, so the area will be equal to pi times the radius squared, pi x squared. We just right now found out that x equals to 4 over 3 units, so the area of our circle will be equal to pi. X is 4 over 3, therefore x squared is 4 over 3 squared. So the area of our circle is equal to pi times 4 over 3 squared. So it is pi times 4 over 3 squared. 4 over 3 squared equals to 4 squared, it is 16. Over 3 squared, it is 9. So in conclusion, we found out that the area of this circle, that is the area that we are looking for, it is equals to either 16 pi over 9 square units, or in terms of numbers, it is equals to 5.585 square units. And that is the answer to our question. Repeat again. The area of this circle equals to either 16 pi over 9 square units, or in terms of numbers, it is equals to 5.585 square units. In the next step, I will summarize the lecture. In this lecture, we found out the area of this circle. So in the drawing, we have quadrilateral ABCD. Inside this quadrilateral, we have this circle. In addition, we know that the length of side AB of the quadrilateral is equal to 2 units. BC equals to 8 units. DC is equals to 8 units. This is angle DCB that is equals to 90 degrees. And angle ABC equals to 90 degrees in its size also. Our mission is to find out the area of this circle. In order to find out the area of the circle, we did the construction. We extended sides DA and side CB of the quadrilateral until they touch each other. Again, we extended side DA and side CB until they touch each other. They touch each other at this point, so we define the touching point between the two sides as M. So here we actually extended side CB. We extended side CB by a straight line. CB, line segment CB is one side of the quadrilateral, therefore it is absolutely a straight line. When we extended the straight line CB by a straight line, the result is CM. When you extend a straight line by a straight line, the result must be a straight line, therefore CM is a straight line. Again, line segment CM is a straight line. So if we focus on the upper side of the straight line CM at point B, here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles from one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of CM at point B? We have this angle that is equal to 90 degrees plus the missing angle, here angle ABM. In total they must be equal to 180 degrees according to the rule that I mentioned. And therefore the missing angle here, angle ABM, that is to say angle ABM, must be equal to 90 degrees. Again, in order to complete the sum of the angles on the upper side of CM at point B to 180 degrees, the missing angle here ABM must be equal to 90 degrees. So in the right triangle ABM, this angle equals to 90 degrees. We define angle A and B as theta. Therefore, the missing angle must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta, it is equal to 90 degrees. And 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. Then we focus on the big right triangle ATG. On the big right triangle ATG, this angle equals to theta, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus theta, exactly as it is true in this triangle ABM, the right triangle ABM. Then we proved that the big triangle TGM is similar to the small triangle ABM. Why those two triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, it is a common angle that belongs to both triangles, so angle theta equals to itself. And finally, those two angles are both equal to 90 degrees minus theta, and therefore they are equal to each other. So we actually proved that all the three angles in the big triangle TGM correspondingly equal to all the three angles of the small right triangle ABM. Therefore, those two right triangles are similar to each other according to angle similarity rule. And from the fact that the two right angles are similar to each other, we derive that the following relationship exists between their sides. That GM in the big triangle over AMB in the small triangle is equals to TG in the big triangle over AB in the small triangle. I repeat again. Actually, we relate to triangle MDC, of course. We relate to triangle MDC. And triangle MDC, this angle equals to theta, this angle equals to 90 degrees. Therefore, the missing angle here equals to 90 degrees minus theta. Then we prove that the big triangle DCM is similar to the small right triangle ABM. Why those two triangles are similar to each other? First of all, those two angles are equal to 90 degrees, therefore they are equal to each other. This is angle theta, this is a common angle that belongs to both triangles, so angle theta equals to itself. And those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually prove that all the three angles in the big right triangle DCM are corresponding equal to all the three angles in the small triangle ABM. Therefore, those two right triangles are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that CM in the big triangle over MB in the small triangle is equals to DC in the big triangle over AB in the small triangle. I repeat again. MC over MB equals to DC over AB. MC equals to MB plus BC, that is to say MC equals to MB plus BC, that is 8, so in total MC equals to MB plus 8. Again, MC equals to MB plus 8 over MB, that is equals to DC is 8 and AB is 2, so DC over AB equals to 8 over 2, that is 4, so MB plus 8 over MB equals to 4. We multiply this equation by MB and found out that 4 times MB equals to MB plus 8. We subtracted MB from this equation and finally found out that 8 equals to 4 MB minus MB is 3 MB, so 8 equals to 3 MB. We divided this equation by 3 and finally found out that MB equals to 8 over 3 units. MB 97 MB equals to 8 over 3 units. Then we implemented the Pythagoras theorem on the right triangle ABM. According to the Pythagoras theorem, AM square equals to AB square plus MB square. Repeat again, the right triangle AMB. AM square equals to AB square plus MB square, so AM square equals to AB square. AB is 2, so AB square is 2 square, that is 4, plus MB square. MB is 8 over 3, therefore MB square is 8 over 3 square. So AM square equals to 4 plus 8 over 3 square. So AM square equals to 4 plus 8 over 3 square equals to 8 square, that is 64, over 3 square, that is 9. Then we multiplied 4 by 9 and then we divided by 9 in order to work on factor with 64 over 9. So 4 times 9 is 36. So in total, in the numerator we have 36 plus 64 over 9. So 36 plus 64, it is 100, it is 100 over 9. So AM square equals to 100 over 9. We took a root out of this equation and finally found out that AM equals to the square root of 100 over 9. The square root of 100 over 9 is the square root of 100, that is 10, over the square root of 9, that is 3. So in total, AM equals to 10 over 3. I put AM equals to 10 over 3 units in its life. Then I presented to you rule number 1 and we implemented rule number 1 in our drawing. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. Tangent AB is tangent to a circle at point M. The radius OM is drawn to point M, that is the point of tendency. Whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees. Implemented rule number 2 in our drawing. So, first of all, we define the center of this circle as O. We define the point of tangency of tangent AB with this circle as M. We join points M and O together by certain. Point O is the center of the circle, point M is the point of the circle itself. Therefore, OM is the radius of the circle that we define as X. We have the radius OM that is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever we have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees and this angle equals to 90 degrees. So according to rule number 1, we define the point of tendency of side BG with this circle as M. We join points O and N together by a straight line. ON is the radius of the circle that is equal to X. The radius ON is drawn to point N, that is the point of tendency of tangent BG with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent BG will be perpendicular to the radius NO. If BG is perpendicular to NO, it means that this angle equals to 90 degrees and this angle equals to 90 degrees. So in quadrilateral OMBG, we have 1, 2, 3 right angles. The sum of right angles is 270 degrees, plus the missing angle. In total, they must be equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Then we draw perpendicular on BC in such a way that it will be also tangent to the circle at point H. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. Then we extended perpendicular DH until it touches side DM of the triangle. We define the touching point as T. So tangent TG is tangent to this circle at point H. We join points O and H together by straight line. The radius OH is drawn to point H, that is the point of tendency. Therefore, tangent TG must be perpendicular to the radius HO, that is to say this angle equals to 90 degrees and this angle equals to 90 degrees. So in quadrilateral OHGN, we have 1, 2, 3 right angles. Therefore, the fourth angle must be equal to 90 degrees, according to the rule that I already mentioned, that the sum of the angles in any quadrilateral is equal to 360 degrees. So angle AHOM equals to 90 degrees plus 90 degrees, it is equals to 180 degrees. Again, angle AHOM equals to 180 degrees in its size. Any angle that is equals to 180 degrees must be a straight line. So HOM is a straight line. If HOM is a straight line, then HM is also a straight line. But the straight line HM touches the circle at point H and M, therefore HM is a chord that passes through point O, that is the center of the circle. Any chord that passes through the center of the circle must be the diameter of the circle. Therefore, HM is the diameter of the circle. Repeat again. Here, HM is the diameter of the circle. Then we focused on quadrilateral MH BG. Inside this quadrilateral, we have 1, 2, 3, 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to quadrilateral MBGH as a rectangle. And we know that the opposite sides of rectangle are equal to each other. So the opposite sides of rectangle MHBG are equal to each other. That is to say MH equals to BG. Repeat again. Rectangle MHBG, MH is equal to BG. And from this equation, BG equals to HM equals to the diameter, we derive that BG is also the diameter of the circle. And the diameter of any circle is twice as long as the radius, and the radius of this circle is X. Therefore, the diameter BG must be equal to 2X. So we can write down here that the diameter BG equals to 2X. Then we focused on the right triangle MTG. In this right triangle MTG, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. Then we prove that the big right triangle TGM is similar to the small right triangle ABM. Why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, that is a common angle, it belongs to both triangles, so angle theta equals to itself. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So we proved that all the three angles in the right triangle TGM are corresponding equal to all the three angles in the right triangle EBM. Therefore, those two right angles are similar to each other according to angle similarity rule. And from the fact that those two right angles are similar to each other, we derive that the following relationship exists between their sides. That MG in the big triangle over MB in the small triangle, it is equal to TG in the big triangle over AB in the small triangle. Repeat again. MG over MB equals to TG over AB. What is the length of MG? MG is MB plus BG. That is to say MG equals to MB, that is 8 over 3, plus BG, that is 2x. So in total, MG equals to 8 over 3 plus 2x. Again, MG equals to 8 over 3 plus 2x over MG, that is 8 over 3. And it is equal to TG. TG is unknown, so we left it as it is, over AB, that is 2. So in conclusion, we found out that 8 over 3 plus 2x over 8 over 3 equals to TG over 2. Then we multiply 2x by 3 and then we divide it by 3 in order to overcome factor with 8 over 3. And found out that here in the numerator we have 8 plus 2x times 3 is 6x. So in total we have in the numerator 8 plus 6x over 3 over 8 over 3, that is equals to TG over 2. So here we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. And we left only with 8 plus 6x over 8, that is equals to TG over 2. Then we cross multiply this equation and we found out that two times 8 plus 6x equals to 8 TG. We divided this equation by 2 and found out that 8 plus 6x equals to 8 over 2 is 4, so in total this expression equals to 4 TG. Then we divided this equation by 4 and found out that TG, the length of line segment TG, is equals to 8 over 4 is 2, plus 6x over 4 is 1.5x. So in total TG equals to 2 plus 1.5x. Yeah. TG equals to 2 plus 1.5x. Then, because of the fact that the big right triangle TMG is similar to the small right triangle AMB, we derive that the additional relationship exists between their sides. We derive that MG in the big triangle over MB in the small triangle is equals to TM in the big triangle over AM in the small triangle. Repeat again. MG over MB equals to TM over MA. I want to explain to you that MG it is equals to 8 over 3 plus 2x over MG, that is 8 over 3 equals to TM. What is the length of TM? TM is TA plus AM. That is to say TM equals to TA plus AM, that is 10 over 3. In total TM equals to TA plus 10 over 3. E of Tm equals to Ta plus 10 over 3 over Ma or Am, that is 10 over 3. So here we multiply 2x by 3 and then we divide it by 3, and then here also we multiply Ta by 3 and then we divide it by 3. So in the numerator we have here 8 plus 2x times 3 is 6x. So in total in the numerator we have 8 plus 6x over 3 over 8 over 3, and there Ta times 3 is 3Ta plus 10 over 3 over 10 over 3. We have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. Here also we have 3 in the numerator and 3 in the denominator, so 3 also will get cancelled. So in this side of the equation we have to leave with 8 plus 6x over 8. On the other side of the equation we have 3Ta plus 10 over 10. Here we cross multiply this equation and found out that 10 times 8 plus 6x equals to 8 times 3Ta plus 10. We open the brackets on both sides of the equation and found out that 8 times 10 is 80 plus 8 times 6x is 60x. That equals to 8 times 3Ta is 24Ta plus 8 times 10 is 80. So we have 80 in both sides of the equation, so 80 will get cancelled. And we left only if 60x, that is equals to 24 TA. We divided this equation by 24 and finally found out that TA equals to 60x over 24, it is equals to 2.5x. TA equals to 2.5x, so we can write here that the length of this line 7 TA, it is equals to 2.5x. Then I copied quadrilateral ATBG here in this pad. This is quadrilateral ATBG that I hold from the original drawing. This quadrilateral blocks a circle. This is the circle that the quadrilateral blocks. So I copied this circle in this new drawing here. The quadrilateral and the circle has 4 points of tangencies between them. That is to say they touch each other at 4 different points. 1, 2, 3, 4. Then I presented to you rule number 2 and implemented rule number 2 in our drawing. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. We have the common external point P. From the common external point P, we have two tangents to the circle, tangent PA and tangent PB. And according to rule number 2, they are equal to each other, this rule. So PA equals to PB. So whenever you have a common external point and you draw two tangents from a common external point to a circle, then the length of the two tangents must be equal to each other. Again, in this case, PA equals to PB. We implemented rule number 2 in our drawing. We focus on the common external point A. From the common external point A, we have two tangents to the circle, tangent AM and tangent AN. According to rule number 2, they are equal to each other. That is to say, AM equals to AN. So if we define the length of AM as 8, then AN must be also equal to 8. Then we focus on the common external point B. From the common external point B, we have two tangents to the circle, tangent BN and tangent BY. And according to rule number 2, they are equal to each other. That is to say, BN equals to BY. So if the length of BN is B, then BY must be also equal to B. Then we focus on the common external point G. From the common external point G, we have two tangents to the circle, tangent GY and tangent G edge. And according to rule number 2, they are equal to each other. That is to say, GY equals to G edge. So if we define the length of G edge and C, then GY must be also equal to each other, to C, because they are equal to each other. And finally, we focus on the common external point T. From the common external point T, we have two tangents to the circle, tangent TM and tangent TH. And according to rule number 2, they are equal to each other. That is to say, TM equals to TH. So if we define the length of TH as D, then TM must be also equal to D. Then we added side TA to side BG to the opposite side BG. TA plus BG. TA equals to A plus B. BG equals to B plus C. So in total, TA plus BG, AP plus BG equals to A plus D plus B plus C. You can change the orders of the four letters. Instead of A plus D plus B plus C, you can write down that A plus B plus C plus D. Those two expressions are equal to each other. We just change the orders of the letters. Then we added side AB to side TG. AB is A plus B and TG is B plus C. So in total, AB plus TG, AB plus TG equals to A plus B plus C plus D. So both those two expressions, they are both equal to the same expression, A plus B plus C plus D, therefore they must be equal to each other. That is to say, T plus BG, this expression equals to AB plus TG. Okay? AT plus BG equals to AB plus TG. So here we have AT equals to 2.5x, so we substitute AT in the equation by 2.5x, plus BG. BG equals to 2x, so we substitute BG in the equation by 2x. And it is equals to AB. AB is 2, so we substitute AB by 2, and finally plus TG. TG is 2 plus 1.5x, so we substitute TG in the equation by 2 plus 1.5x. And finally we found out that 2.5x plus 2x equals to 2 plus 2 plus 1.5x. 2.5x plus 2x is 4.5x. So 4.5x equals to 2 plus 2, that is 4, plus 1.5x. We subtracted 1.5x from this equation and finally found out that that 4.5x minus 1.5x is 3x, so 3x equals to 4. We divided this equation by 3 and finally found out that x equals to 4 over 3 units in its length. X is the radius of this circle, so we found out that the radius of this circle equals to 4 over 3 units in its length. What is the area of this circle? That is the area that we are looking for. The area of any circle, here the square bracket is the sign for the area. It means the area of a circle is equals to pi times the radius of the circle squared. If the radius is r, then it is pi r squared. In our specific circle, we define the radius as x, so it is pi x squared. The area of our circle will be equal to pi x squared according to this equation. We just right now found out that x equals to 4 over 3, so we can substitute x in this equation by 4 over 3. We did it and found out that pi x squared is pi times 4 over 3, that is x. So 4 over 3 square will be equal to x squared. So the area of the circle equals to pi times 4 over 3 squared. Pi times 4 over 3 squared. 4 over 3 squared equals to 4 squared, that is 16. Over 3 squared, that is 9. So in conclusion, we found out that the area of this circle equals to either 16 pi over 9 square units, or in terms of numbers, it is equal to 5.585 units. 5.585 units. 5 square units. Again, the area of this circle equals to either 16 pi over 9 square units, or in terms of numbers, it is equals to 5.585 square units. Okay, thank you very much.